Hello, my name is Anthony, and this is my tape charge lab. The purpose of this lab was to investigate the nature of charged objects in the real world using charged tape as an apparatus. This lab for me consisted of two parts, the experimental part and the computational part. The fundamental principles that I was most concerned with would be Newton's second law, which allowed me to extrapolate the conclusion that the electric force must be equivalent to the gravitational force, which is the principle that you use to determine the charge on the tapes. And also another one is the Coulomb's equation, which I use to derive the charge on tapes after equating the forces. You can see a little bit of how I did that on the code versus, you'll see later how I did that more using the experiment. After charging the tape, I noticed that the sleek side of the tape, the side without all the sticky stuff on it, was attracted to pretty much any neutral surface, right? So like a wall, a table, a bed sheet, anything like that, it would be attracted to. However, when I brought it near another charged tape, it was repelled. After checking with a negatively charged pen, which I charged using like my comforter, which is made out of a kind of a faux, I guess like animal fur, I discovered the tape was positively charged because the pen was negatively charged by the bed. The experiment portion of this lab consisted of charging two U-tapes by placing one just neutral tape on a flat surface like a table, and then using that as the base to charge a couple of other tapes, right? I took two books and I placed them parallel to each other, and I attached one of the charged tapes to the top of the two books. And then I brought the other one closer, the other charge tape from below closer until I noticed floating, right? The sources of error as I did this, of course, was the floating was relatively slight. I was expecting a little more pronounced, but it was not. However, there was definitely movement, and that movement, without the tapes getting too close to each other, is what I used to to determine if it was floating or not, but that might not be exactly precise. And the measured distance I did while holding the tape and then using a ruler. So that could definitely have led to some imprecisions in the measurements, right? A few of the assumptions I had to make for these other conclusions, such as, the electron deficiency, the charge on the tape and all that, all those ratios, is that the tape was an atom thick. We were told that we were going to use like an order of magnitude of like 1 times like 10 to the negative 10. But of course, that doesn't take into account the thickness of the tape and other things stipulated in the prompt, such as air resistance, the tape being seen as a point charge as opposed to the charges being distributed, and that even though there could have been a chance for the U tape to absorb a different charge based on technique or whatever, that both tapes had the same charge. The assumptions I made for the coding parts, I tried to equalize it by using the very same assumptions, such as, not having air resistance, not using an atom, thick of tape, gravity being calculated at 9.8, same stuff like that, same constants, right? Same mass for both tapes. And I also had the calculations made by the system just using the basic Coulomb's law like I had in my experiment. However, I did get two separate charges. As you saw in the last slide, this charge is a little bit different from that previous slide. And, I think that's because this computational model is just using just straight, Coulomb's law on, just point charges and all that. Of course, the system only takes into point charges. However, in the real world, there was complex interactions between the charges. Most likely, those tapes were not equivalently charged. Several things like that led to a difference in response between both the experiment and the computational model. For the what if question, the charges changing sign, that shouldn't affect anything as the tapes initially repelled each other, so they were the same charge. So if they both flop charges, they're still the same charge, so they're still going to repel each other, and it's the same magnitude of charge. So it's going to be the same, force. And the reason why you don't want to be touching all up on the tape is, you basically act as a ground for the charges, so the charges would leach off. Thank you very much for listening to my presentation.